In the previous video, I had a very lengthy explanation of what the definite integral is. So in this video, I'm going to show you how to use the definite integral to represent the area under a curve and then to evaluate that integral geometrically. Later on, we'll compute definite integrals algebraically. So what we're going to do is we're going to take the integrand, which in this first case is 4 minus x, and we're going to draw that graph. So I'm going to draw an x and a y-axis. And I know that my lower limit and my upper limit is -1 to 4. So I'm going to plot -1, 0, 1, 2, 3, 4. And then I'm going to draw the graph of 4 minus x. So this graph has a y-intercept of 4. And then the slope is -1. So this is an equation of a line. So I'm going to draw the line here. I'm just going to kind of miss my point. All right, so what I'm going to do is then draw lines that go down to the x-axis. And then what I'm going to do is I'm going to calculate the area underneath this curve, which would be this triangular area underneath here. So the integral of 4 minus x from -1 to 4 is going to be the area of a triangle. And we can see from here that the base is 5 and the height, 1, 2, 3, 4, 5, is also 5. So we have 5 times 5 divided by 2 to find the area of a triangle. So we get 25 divided by 2. All right, let's take a look at the next one. So the next one's a little bit odd because it just has the number 3 there. So the number 3, remember that the integrand is actually y equals. So when I say 4 minus x, I'm actually saying that y equals 4 minus x. And then here, I'm actually saying that y equals 3. So what this means is that y equals 3, I actually have a horizontal line. So I'm going to draw a horizontal line at 3. And then I can see that my lower and upper limit are from 1 to 5. So 1, 2, 3, 4, 5. And then I'm going to mark in red that area from here to here. And so I'm going to find the area of this shaded part, which is the area of a rectangle. So the integral of 3 from 1 to 5 is the area of a rectangle. And the base I can see is 1, 2, 3, 4. And the height of my rectangle is 3. So 4 times 3 is 12. All right, let me show you one other example. And the next one I'm going to show you is this absolute value here. So I want you to sketch the region whose area is represented by this integral from -1 to 2, absolute of x divided by x dx. And then we're going to evaluate the integral using geometry. So to draw the picture, I know it goes from -1 to 2. Okay. So to understand this better, what I have is that f of x, I actually get two functions here because it has the absolute value. So I'm going to write this as curly brackets. So my first possibility is that the x can be negative. So I have negative x over x, which equals -1. So that occurs when my x value is from -1 to 0. Then at 0, it changes. So then I get x divided by x, because x would be a positive number after 0. And this gives me a value equal to 1. So this occurs from 0, less than or equal to x, and less than or equal to 2. Notice that my lower limit is -1. That's part of the first part of the absolute value. And the 2 is part of the second absolute value, which is positive. So it's actually my upper limit, which is my end. All right, so drawing this picture, I have from -1 to 0, from here to here, so 0. I have a y equals to -1. So I have a horizontal line right here. And then from 0 to 2, I have a horizontal line at y equals 1. So that would be from here to here. All right, so let me fill it in with some red here. So from -1 to 0, so from here to here, it is -1. So I'm going to have this area down here below the x-axis. And then from 0 to 2, I have the line y equals 1. So from 0 to 2, I have this area underneath the line, but above the x-axis. So calculating my area, I can say that the integral is equal to, so the first one has a base of 1 times the height of -1. And my second rectangle have a base of 2 times the height of 1. So -1 plus 2, which equals an area of 1, which is the answer to this integral here.